All right, welcome. In this video, we're going to be working Algebra 2 Homework 6.1. So that's going to be solving and graphing polynomial equations. Equations degree higher than 2. So in this class, we're going to solve equations primarily by factoring. Okay, so I'm going to look at these 4, and I'm going to say this is, solved by factoring. So the first one, I'm always going to start looking for a greatest common factor. X to the 3, x to the 2, negative 6x, those all have at least one power of x in them, so I'm going to factor out that x. Now, this quadratic inside the parentheses, this is something that I can factor as well, because I can think of two numbers that multiply to negative 6 while adding to positive 1. It's going to be positive 3 and negative 2. So I've got x times x plus 3 and x minus 2. All multiplying together to equal 0. And now I'm going to apply the zero product property. I'm going to say, okay, if these three things are multiplying together to equal 0, it's because one of them is 0. So either x is 0, or x plus 3 is 0. That would mean that x needs to equal negative 3. Or maybe x minus 2 is equal to 0, and that would be where x is equal to 2. Get another sheet of paper to put underneath this one. Yeah, so number 2, I'm going to factor this. I'm looking for a greatest common factor. I don't see an x in all 4 terms. They're not all 4 even, so I'm not going to be able to factor out the 2 either. So I'm going to have to just do group and factor. Okay, I'm going to just have to hope that I can do group and factor, and so I'll look at the first 2 and say, what's common to these? Well, 2 powers of x. So x squared times 2x minus 5. And then negative 4x plus 10. What can I factor out of that? Okay, can't factor out a 4 because 4 doesn't divide 10. So I'm going to factor out a negative 2. Yeah, and then I'll be left with 2x minus 5. Okay, that's good. That's equal to 0. Okay, now I'm going to factor out the 2x minus 5. Okay. And if these two things are multiplying together to equal 0, one of them has to be 0. Now, you could try to factor this. Okay, it's not exactly a difference of 2 squares, but a person could factor this with x plus the square root of 2 times x minus the square root of 2. And I'm going to get plus or minus the square root of 2 as one of my solutions. But since that's not really typical factoring that we do, I'm going to say, okay, at this point, either 2x minus 5 needs to equal 0. That would be 2x equaling 5 and x equaling 5 divided by 2. Or maybe x squared minus 2 needs to equal 0. That would be x squared equaling 2. And if I took the square root of both sides, I'd need to remember that plus minus, right? Because I could square the square root of 2 and get 2. Or I could square this number and also get 2 because, negative 1 times negative 1 is positive 1. Okay, so these are my 3 solutions. Next one, 3x to the 3 minus 9x equals 18x squared. Okay, these first 2, they came set equal to 0. Okay, these next 2 are appearing to not be set to 0 at the beginning, so that's going to be part of our job. Okay, when we're solving polynomial equations, we always need to set them equal to 0 if we're going to be using factoring, because the reason we use factoring is to make use of the zero product property and make use of the zero product property, we got to have it set equal to 0. Okay, so set to 0 first. That's my advice to you. And there's my black pen. So I'm going to start by setting it equal to 0. I'm going to subtract 18x squared. Okay, I see. I've got a greatest common factor. I've got 3 dividing all 3 of these things, and I've got an x. That's supposed to be an x to the 3. All right, so I'm going to factor out a 3x, and I'll be left with x squared minus 6x minus 3. Make sure I didn't make an error there. I think I made an error when I was typing this. Yeah, I bet that I was going for x squared minus 6x plus 9? I don't know if I'd messed up the number and the constant. I don't know what I was going for here. But I kind of like the where this is, right? Because you think about it, can you think of any numbers that multiply to -3 while adding to -6? I don't think so. That's not going to happen. So we can still find the solutions to this. We're going to use a quadratic formula. Maybe that was what I had intended all along. I don't know. So either 3x equals 0, and that's going to give me x equals 0. Or it's the case that x squared minus 6x minus 3 is equal to 0. Okay, now this is going to have two real solutions because a and c have opposite signs. Okay, that will be the case in general. If you're trying to solve a quadratic and a and c have opposite signs, there will be two solutions. Okay, so x is going to equal negative b plus or minus the square root of b squared minus 4 times 1 times negative 3. Well, that would be plus 12 divided by 2a is, okay. Now the square root of 48 is divisible by 16. So maybe I'll go off and do a little bit of arithmetic off to the side of a post-it note. So I'm interested in simplifying the square root of 48. And I know that it's, well, maybe you're not thinking of it as divisible by 16, but you're thinking of it as 12 times 4. Okay, so 4 times 12, that's 4 times 3. And then I'm going to say, okay, well, the square root of 4 is 2, square root of 4 is 2, square root of 3 is not an integer. So this is 4 root 3. However you want. All right, so 6 plus or minus 4 root 3, all divided by 2. Okay, so that's 3 plus or minus 2 root 3. So 3 plus 2 square root of 3 and 3 minus 2 square root of 3. And then, okay, all right, this looks like I'm going to need to be doing group and factors, so I'm going to start by setting it equal to 0. So I'm going to also slide that over so you can see that work a little more clearly. Okay, I'm going to do group and factor. Look at the first two. Oh, wait, no, there's a greatest common factor. There's x in all of these things, so I'm going to factor that out. Okay. Now I'm going to do group and factor. Okay, and then I'm going to factor x minus 2. And then I'm left with x squared plus 10. Okay, we don't have anything for sum of two squares, so we're not going to be able to factor any farther than this. Okay, now at this point, either x equals 0, or x minus 2 equals 0, or maybe x squared plus 10 equals 0. That would be where x squared equals negative 10, and we're not going to be taking any real numbers and squaring them and getting negative 10, so this is not going to contribute any real number solutions. Okay, maybe later in the course we'll see that it's going to contribute to other solutions that would fill out the 4 solutions you'd expect to get from a 4th degree polynomial. Okay, so in this case, these are my only solutions, are 0 and 2. All right, now we're going to write a standard form polynomial that fits the graph pictured below. All right, now I don't know that we're going to be able to fit it exactly. I mean, I don't know what the lead, basically what I'm saying is I don't know what the leading coefficient of this graph is, and we don't have any way to tell being given I don't know, the exact coordinates of another point that's on the graph that's not a 0. All we're seeing here are the zeros, really. Okay. But I do see it's a third degree, it looks like a 3rd degree polynomial with a positive leading coefficient because it's coming from below and then going up, just like the graph of y equals x cubed, and it's got 2 turnaround spots. And, okay, a 3rd degree polynomial can have up to 2 turnaround spots. Okay, anyway, so I'm going to start by writing it kind of like in a factored form. Okay, so that's, the zeros are x equals 0, x equals 1, and x equals 3. And we can make use of the factor theorem, okay, if an x coordinate is a 0 of a polynomial, then x minus that x coordinate will be a factor of the polynomial as well. So I'm going to say that it's x minus 0 times x minus 1 times x minus 3. Now that x minus 0, I'm just going to call that x. What I'm thinking, it's really easy to distribute an x, really just end up adding 1 to all the powers. I think I'm going to multiply these two binomials first, kind of do some FOIL, and then I'll distribute in the x at the end. Okay, so this will be x times x squared minus 3x minus another x is minus 4x, and then plus 3. Okay. And then this will be x to the 3 minus 4x to the 2 plus 3x. That'll be great. All right, now these ones on the back side are asking for a sketch of the polynomial with labeled x and y intercepts. And I'm thinking I might want to space my work out, so I'm going to give myself extra room to work. So y equals x to the 4 minus 16. Okay, I think I'm going to kind of graph this two different ways, right? In the notes, we just were saying, okay, if it's just x to the 4 minus 16, it's going to look exactly like y equals x to the 4th, except it's just going to have a y-intercept of negative 16 instead of going through the origin. So I could sketch it like that. Okay, that's going to be negative 16. And we know x to the 4th looks a lot like y equals x squared, except it's flatter in the middle and steeper on the sides. Oh, that was really, really rough. Okay, and then we can, we'll label our y-intercept and our x-intercepts. I can just say this is going to be 2 and negative 2 because I'm thinking, what number can I take to the 4th power and get 16? Well, I can take 2 to the 4th and get 16. I can also take negative 2 to the 4th power and get 16. But maybe you want to do this with factoring. This is a difference of 2 squares, so this is x squared plus 4 times x squared minus 4. And can't do anything with this, but I can work with this. Okay, and if I wanted to do it, starting with the zeros and the end behavior, so I'd have negative 2 and 2 are going to be points that are on the graph. And the end behavior for a 4th degree polynomial is that with a positive leading coefficient is that, on both sides we're going to go up. So really what it's going to look like is, and we don't, when we're doing this, we don't exactly know what it looks like, but overall these are both perfectly fine sketches. And negative 2, 2, if we want to label the y-intercept, we're going to go down here, and that's still going to be at 16. Okay, it's a little too steep in the middle and shallow on the sides, but whatever. These are essentially the same. If you gave me either one of these, I'd be happy with either one. Right, number 7. Hopefully this one's a little more interesting. Yes, y equals negative x cubed minus 3x to the 2 plus x plus 3. Okay, now my advice to you, when you see that the leading coefficient is negative, okay, we need to make note of that. Okay, we're looking at a 3rd degree polynomial with a negative leading coefficient. So we know that the end behavior, it's going to come from above, and it's going to eventually go down. But when we're going to factor it, all the time you've been factoring, you've been trained to factor kind of with the expectation that the leading coefficient was positive. And me personally, I'm not very good at factoring with a negative leading coefficient, especially like a quadratic or something. So I always just recommend factoring out the negative at the beginning. And then it makes it a little easier to look at. And so I'm going to do group and factor on this. You can do group and factor on the original expression if you want. I'm just not going to do that here. No, that's where I would be prone to making errors. So x squared times x plus 3 minus 1 times x plus 3. And then I'm going to factor out x plus 3. And I'll be left with x squared minus 1. And I can go do a little bit more factoring. Okay, so I've got it factored all the way down. I've got 3 factors for my 3rd degree polynomial with a negative leading coefficient. So I'm going to sketch an x-axis, label my zeros. So negative 3, negative 1, 1. And then I'm going to start drawing by thinking about the end behavior. So a 3rd degree polynomial with a negative leading coefficient. Let's see, right there. Okay, y equals negative x to the 3. We saw that that looks like that. And now the middle of the graph of this polynomial is not going to look the same as that, but the edges will look the same. So if I just kind of cover that up, on the left it's going up, and on the right it's going to be going down. Okay, so it's going to be going up on the left and down on the right. Okay, and now we're just going to sketch the graph of a polynomial, which is continuous and smooth. So we're just going to kind of pass through these points. I'm going to have to turn around to get back there. I'm going to go up for a while, and then I'm going to have to turn around to get back to 1. And then, okay, it's a pretty decent sketch in my mind. But it did say to label the y-intercept. So I am going to say, oh, all right, hey, the y-intercept is 3 right there. And I know that the y-axis is going to come between -1 and 1, so it'd be, I don't know, somewhere about like that. I don't know that that's necessarily at the very top of that of the graph. I'm not necessarily committing to that, but I am going to say that that is y-coordinate of 3. We don't know enough about math to say for sure whether this is at the top of that hill. That's calculus. That's what you would learn about in that class. Okay, looks like I'm going to need some more paper. I knew I was going to need more room for these. All right, so number 8. You can't even see that. F of x equals 2x to the 3 minus 2x to the x. Okay, we're going to start by factoring it. I'm seeing a greatest common factor. I'm seeing 2 in all of this, and I'm seeing x. So I'm going to say 2x multiplied by x squared minus x minus 2. Okay, then this thing, if I can think of two numbers that multiply to -2 and add at -1, I'll be able to factor it. So I'm thinking x minus 2, x plus 1. And I lost track. Oh, okay, now I'm going to label my axes. Or I guess just my x-axis. 0, -1, and positive 2. Okay, and I know that these are not spaced out according to their actual distances, but I prefer to just always make them evenly spaced. It makes the graphs look pretty nice. Okay, then, I mean, since it asks for a y-intercept, I'm going to draw the y-axis because I've already got 0 labeled. So I'm just going to say it's right there. Got my x and y axes. Okay, this is a third-degree polynomial with a positive leading coefficient. So I need to think about y equals x to the third. You can also just think about y equals x if you just have that graph in your mind. But we just learned about y equals x cubed. So I figured I might as well just kind of like remind you about it in this video. Okay, so that's what y equals x cubed looks like. It's going to share the same in behavior. On the right, it's going to be going up. And on the left, it's going to be going down. Okay, so I'm going to start with that. So I'll be going up. I'll pass through here. I'm going to go down through that point, and then I'll be going up there. Okay, and I've got myself a nice-looking sketch. All right, the last of these sketch the graph problems is a fourth-degree polynomial with a positive leading coefficient. So I didn't do it on the first one, but that x to the 4 minus 16 was relatively straightforward to graph. So I don't think you needed that much to think about with the end behavior because it was so close to the graph of y equals x to the fourth. Now, a fourth-degree polynomial with a positive leading coefficient. That's even degree positive leading coefficient. Just think about y equals x squared. Okay. I'm going to sketch the graph of y equals x squared because we all know what that looks like. We can all agree that that looks like that. And so, you know, who knows what's happening in the middle? We don't know what's happening in the middle of this graph, but on the outsides, this thing will look the same because it's even degree positive leading coefficient. So my first job, factor this. Okay, I'm looking at this, and this is one that looks like a quadratic, except it's x to the 4, x to the 2. So I know it's going to factor with x squared plus some number times x squared plus some other number. And I'm looking for those numbers to multiply to 36 and add to -13. Okay, so 18 times 2, I don't think so. 6 times 6, close, but not it. This is 9 times 4. Okay, so I'm thinking -9 and -4 will make this work. And then these are two differences of squares. So I'll be able to say, all right, x plus 3, x minus 3, x plus 2, x minus 2. I'm going to go over here, and I'm going to kind of label these zeros, -3, -2, 2, and 3. And okay, fourth degree polynomial, positive leading coefficient. I already drew it over here. Start with the end behavior. It's going to come from above, and it's going to eventually go up. So it's going to come down, and then it's going to go back up, and then it's going to come back down. Going to go up like that. I feel like I am pretty sure on this one, based on kind of the symmetry of the situation, that the y-axis is going to come down right at the top of that, but I'm going to label that as 36 also. And now I've got myself a really nice sketch. Okay, I'm not remembering if I labeled the y-intercept. Yeah, I did, yeah, okay. We're good. We labeled the x and y-intercepts. And that's how we're going to sketch polynomials. And we'll be doing a whole lot of that next time, just with some other situations. So we're going to get plenty more practice on this. Okay. Then the last few problems, it's like, hey, just find the degree leading coefficient at y-intercept and then describe the end behavior. We can do that. Okay. So degree, I guess maybe I'll kind of like go through and label each of the aspects for each of these 4 functions. Yeah, I think that's going to be the thing to do. So I'm going to do the degree in blue. Degree on this one is 3 because that's the highest exponent I'm seeing. This one, okay, I'm not going to multiply this out, but I'm going to think about what would happen if I did. If I multiplied 4x times 2x plus 1, I'd get 8x squared plus 4x. And then if I multiplied 4x times 2x plus 1 times x minus 3, I would have 3 total powers of x. So this one's also going to be degree 3. This one's degree 4 because that's the highest exponent I'm seeing. And then this one's also degree 4 because that's the highest exponent I'm seeing. Okay, leading coefficient. All right, maybe we'll do that in red. There we go. I haven't used this green pen in a while, so maybe I'll. What happened to it? Got something on it. Okay. So the leading coefficient is the number attached to the highest power of x. So in this case, the leading coefficient is -2. Okay. On this one, I can't see it. I have to think about what would happen if I was to multiply this all out. Okay. If I was to multiply, let's actually not think about the 4x first, let's just think about the 2 binomials. If I was to do FOIL on this, I would get 2x squared plus some other stuff. The other stuff would have lower powers of x. Okay, because this is the degree 3, I'm really only interested in the number that's going to be attached to x to the 3 power. Okay, so I'll have 2x squared times 4x would be 8x to the 3. So that leading coefficient would be +8. Okay, these two are going to both be easier to see because it's just attached to the power of x. And so that's 1/2. And -7. Okay. Leading coefficient, y-intercept. Okay, we find the y-intercept by plugging in 0 for x. And for these 3, it'll be real easy because it's the constant. Okay, and I showed you that in class, that if you just plug in 0, you're going to get that constant left over. So the y-intercept is the point where x is equal to 0, and in that case, y will equal 5. In this case, I plug in 0, I'm going to get 7. Or it's the constant is 7, and the constant is 2 over here. So y-intercept is going to be 0 and 2. Okay, this one's a little trickier. Remember that the y-intercept is the point that corresponds with x equals 0. So that's g of 0, and I'm just going to plug in 0 for x. So that's going to be 4 times 0 times 2 times 0 plus 1 times 0 minus 3. Okay, and now I knew this was going to be 0 as soon as I saw that happen, but maybe we don't have one like this. Maybe it's like 4x plus 5 times 2x plus 1 times x minus 3, and then we would need to multiply all that stuff together. So this is all 0, and so I'm going to say that is at 0 and 0. All right, now the end behavior. For this one, I'm thinking third degree polynomial with a negative leading coefficient needs to look like the graph of y equals -x cubed. And that's not going to be a sufficient description of the end behavior, at least in my class. Okay, in my class, the description of the end behavior needs to be a sentence. Okay, Doesn't need to be the most well-written sentence, and it doesn't always have to have all exclusively words in it, but it does need to be written. So I'm going to say, as x approaches positive infinity, y is approaching negative infinity. Yeah, because it's third degree with a negative leading coefficient. And as x approaches negative infinity, y is approaching positive infinity. Okay. This is a third degree polynomial with a positive leading coefficient, so it's going to look like the graph of y equals positive x to the 3, which, okay, that's drawn better sketches, but okay, as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, the farther we go to the left, farther down the graph is going to go. Y is approaching negative infinity. Okay. Then over here, a fourth degree polynomial with a positive leading coefficient. That's an even degree positive leading coefficient. Think about y equals positive x squared. Okay. And we know what that looks like. Looks like that. That's pretty decent. Okay, so as x approaches positive infinity or negative infinity, it's doing the same thing. They're both going up. So I'm going to not write out two sentences. I'm going to say as x approaches positive or negative infinity, y is approaching positive infinity. Okay. And then a fourth degree polynomial with a negative leading coefficient. That's even degree negative leading coefficient. That's going to look like the graph of y equals negative x squared. So as x approaches infinity or negative infinity, both sides are going down. So I'm going to say as x approaches plus or minus infinity, y is approaching negative infinity. And that's all for this homework. Thanks for watching. Hope it helps.